So we're now going to continue our discussion about joint probability distribution. This time we're going to have a continuous random variable. Uh, we will be discussing two random variables which are both continuous random variable. So for this one, a joint probability density function for the continuous random variable x and y, denoted by f sub xy of xy, satisfies the following properties. The density function is always positive for all x's and y's. Um, the integral of the function for wherever it is defined is equal to 1. And for any real number r, for any region r of the two-dimensional space, for any points x and y which belongs to the real number system, the integral of f of xy dx dy would be the probability being set forward. If the joint probability density function of a random variable x and y is f sub xy, the marginal probability density functions are x and y are f sub x of x is the integral of f of xy dy. So if we want the marginal density for x, we integrate it with respect to y. And if you want the marginal density for y, we integrate it with respect to x. So where the first integral is over all the points in the range xy for which x is equal to x, and the second integral is over all points in the range of xy for which y is equal to y. As an example, let the random variable x denote the time until a computer server connects to your machine in milliseconds, and let y denote the time until the server authorizes you as a valid user. Each of these random variables measures the weight from common starting time, and x should be less than y. So assume that the joint probability density function of x for x and y is given by, so the joint density function f sub xy is given by 6 times 10 to the negative 6 e raised to negative 0.001x minus 0.002y for x less than y. So the region with non-zero probability is shaded later. The probability that this joint probability density function integrates to 1 can be verified over this region as follows. So take note that the region being defined is, so this is x, this is y, so x is less than y. So this is the line x is equal to y. So since x is less than y, or y is greater than x, so that would be this region. At this point, y is higher than x. So the equation x is equal to y divides it into two half planes. So this point is, for example, x is 0, y is 1. So this point satisfies 0 less than y. So we include this one. However, this point is 1, 0. So 1 is not less than 0. So we exclude this. So this one is included. So we're going to have the upper triangle dividing the first quadrant. So if we want to check, so we're going to integrate this density function for which it was defined. So if we will be having dy dx, your y is from, so if we're going to have our integral, your y is from x to infinity. So that's why it would be from x to infinity. And while the range of x would be from 0 to infinity. So it would be from 0 to infinity. So doing this integration, it would be equal to 1. So the probability for only one random variable, say for example, the probability of x in between a and b can be found from the marginal probability distribution of x or from the integral of the joint probability distribution of x and y as the given integral. So you have the option to find the marginal density first and then integrate it with the limit being the unknown. So it can be the integral of the marginal density, and then integrating it with the limits being set. So as an example, the probability that x is less than 100 and y is less than 200 is determined as the integral over the dark shaded region to this right side. So our boundary is x less than it is x less than 1000. So this is the boundary, x is equal to 1000, and then this is y equal to 2000. So this is the region being defined. So we can have the integral of f, so we can have it dy dx, wherein y is bounded below by, so your y is bounded below by the line y is equal to x, and it is bounded above by 2000, while x is from 0 to 1000. So that is why we have the integral from x to 2000 and then from 0 to 1000. So I hope you recall your integrals, because this would just be simplified as 0.915. You may use MATLAB to simplify your answer or to solve this double integrals. A privately owned business operates in a drive-in facility and a walk-in facility. On a randomly selected day, let x and y respectively be the proportions of time that the drive-in and the walk-in facilities are in use, and suppose that the joint density functions are the given random variables. So verify condition 2. Condition 1 does not need to be proven because all of the terms are positive. There is no way that this could be negative over the interval from 0 to 1 and 0 to 1. So if you're going to substitute 0, it would be 0. And if you're going to substitute y, it would just be 2 times 1 plus 3 times 1. So that would be 5 over 5. So that would be 2. So it would still be positive. So our goal now is to check for condition 2. That is, if you're going to integrate 2 over 5 is constant. If we're going to integrate 2x plus 3y dx, your x is from 0 to 1, and dy from 0 to 1 as well, it should be equal to 1. So this would be 2 over 5 integral from 0 to 1. So if we're going to integrate this with respect to x, it would be x squared plus 3xy. So the integral of 2x with respect to x is x squared. The integral of 3y, no x term, so that would be a constant. So the integral of dx is x. So x times 3y would be 3xy. And then we're going to evaluate from 0 to 1. So this would be 2 over 5. And then the integral from 0 to 1. So take note that x would be from 1 to 0, from 0 to 1. So that would be 1 squared plus 3y. If you substitute 0, so it would be 0 squared plus 0. So we disregard that. And then with respect to y. So that would be 2 over 5. 1 squared. So is 1. The integral of 1 dy is y plus 3y. So the integral of 3y is 3y squared over 2. This is to be evaluated from 0 to 1. So that would be 2 over 5 times 1 plus 3 over 2 minus lower limit 0 and then 0. So that would be 0. So this is 2 over 5 times LCD is 2. 2 over 2 plus 3 over 2 is 5 over 2. So this is equal to 1. Next question is the probability of xy, which is an element of A, such that this one. So for letter B, the probability that we are looking for is the integral of your x is from 0 to 1/2 and your y is from 1/4 to 1/2, and then we have 2 over 5 times 2x plus 3y dx dy. So this would be equal to 2 over 5. Your x is, so since 1/4 to 1/2 is y, so you have your inner limit to be dy and then the outer limit should be dx. So 0 to 1/2 and then integral with respect to y, so that would be 2xy plus 3y squared over 2 from 1/4 to 1/2 dx. So this would be 2 over 5 integral from 0 to 1/2. So for the upper limit, take note that we're substituting it to y. So that would be 2x times 1/2 minus 1/4 plus 3 over 2 1/2 squared minus 1/4 squared dx. So this is 2 over 5 integral from 0 to 1/2 of 1/2 minus 1/4 is 1/4 times 2 is 1/2 x plus this would be 3 over 2 times 1 over 4 minus 1 over 16. So that's 9 over 32 dx. So for this one, this is readily integrable by your calculator. So we can have the integral. So 2 over 5 times the integral of 0.5x plus 9 over 32, 0.5x times plus 9 over 32 from 0 to 1/2. So this is 13 over 160. Next. Another example, server access time. For the random variable that denotes the time, um, calculate the probability that y exceeds 2000 milliseconds. When you say exceeds 2000 milliseconds, so that would be greater than 2000 milliseconds. So if this is the random variable y, so greater than 2000 would be this region. So that would be this region. So if we will be having, if we have to evaluate this, so we can have the integral of the function dx dy, or we can have the integral of the function dy dx. But there would be problem with this one. So if we will be having a vertical strip, so the upper limit here is negative, is positive infinity. The lower limit here is 2000. However, and then for the x component, it would be from 0 to infinity or 0 to y. So in that case, there would be a difference in the strip here, because this would be from infinity, while the lower limit would be y is equal to x. So we can divide that into two portions. So we can have the integral of f dy dx. So for the first region, it would be from 2000 to infinity. And then x is from 0 to 2000. So x is from 0 to this one. 0 to 2000. And then for this part, we have the integral of f dy dx. So the lower limit would be, for y, the lower limit is x. The upper limit is infinity. While the x component would be from this point to this one. So it would be from, so it extends indefinitely. So it would be from 2000 to infinity. So that's one way of integrating it. However, if we will be having dx dy, if we will be having a horizontal strip, so this would also be the same as the integral of f dx dy. So your x is from 0 to infinity, but your y is from, so it ranges from 2000 to infinity. So in the case of two integrals, it would be this one. So it would be from x to infinity and then 2000 to infinity. So take note that we have these two shapes. So this is 2000 and then this is infinity. So the first one would be this, while for the second integral, it is the triangle. The first integral results into a probability of 0.0475, while the second integral is 0.0025. The total area is 0.05. For the second region, or for the second solution, we can have this one. We can have a horizontal streak such that we are going to evaluate from 0 to infinity, and then after that we integrate from 2000 to infinity. So what we have is the same, 0.05. So let's have marginal densities. So find the marginal densities for x and y. If we are given with f sub xy is equal to 2 over 3 x plus 2y, where x is from 0 to 1 and y is also from 0 to 1. So for marginal density for x, it would be the integral from the given limit of y. So that would be 2 over 3 x plus 2y dy. So that is 2 over 3. The integral with respect to y, so that is xy plus y squared from 0 to 1. So f sub x is equal to, for the lower limit, it would just be 0, 0. For the upper limit, it would be 2 over 3. And then we have x plus 1. This is for x in between 0 and 1. For f sub y, we have 2 over 3 x plus 2y dx. So 2 over 3, this would be x squared over 2 plus 2xy from 0 to 1. So f sub y is 2 over 3. We have 1/2 plus 2y. Let's simplify this as 1/3 of 1 plus 4y, where y is from 0 to 1. So let's have letter C as your activity. These are the references used to create this video.